Okay, got two handouts today. Law of motion and momentum and collisions. 10 questions on each one. Pretty simple. A couple of short videos. I will include those in with this also. Okay? All right, laws of motion. We'll start with that one. A force is anything that can change the state of motion of an object, like a push or a pull. Now, we have gone over this a number of times, I know. Okay? But your test is coming up Thursday. Okay? Yours is Friday. Okay? You use force when you push a letter on a computer key. When you kick a ball, force is everywhere. Gravity acts as a constant force on your body, keeping you secure on planet Earth so you don't just go floating off somewhere. Okay? To describe force, we use the direction and strength. For example, when you kick a ball, you are exerting force in a specific direction. That is the direction the ball will travel. Okay? Also, the harder you kick the ball, okay, guess what? The stronger the force that you place upon it, and the further the ball will go. Okay? A scientist named Isaac Newton came up with the 3 laws of motion to describe how things move scientifically. He also described how gravity works, which is an important force that affects everything. Okay, I always love it when 6th graders talk about how he invented gravity. Okay, he did not invent it. Okay, he didn't invent it. He discovered how. Yeah, and then he described how it works mathematically. So he proved that it did exist. Okay, but it was already here. That was part of the package when God made the world. Okay. Or the universe, actually. Okay? All right. So, first law of motion. The first law says that any object in motion will continue to move in the same direction and speed unless a force acts upon it. Okay? So that means if you kick a ball, it will fly forever unless some sort of force acts upon that ball. Okay? When you kick a ball, a force, of course, immediately starts to act upon it. Friction, air friction, gravity, all of those things starts immediately to work upon it. That's why it doesn't fly around the world and come back and hit you in the back of the head. Okay? It starts to slow down because of all the resistance. Okay? Anybody know what the other name for Newton's first law of motion is? We talked about that briefly. Anybody remember? Okay? Think about what it says. Think about what it says. Okay? Something at rest stays at rest unless acted upon by force. What is it?
Law of motion.
Well, it is a law of motion. It's considered the first law of motion, in fact.
Constant velocity.
No.
Wait,
And if it's in motion, it will stay in motion unless it's acted upon by a outside force.
First law of gravity.
No.
An object is in inertia depends on...
Inertia.
Oh my gosh!
The law of inertia. Okay, very good.
Jimmy Neutron.
All right, now the second law states that the greater the mass of an object, the more force it will take to accelerate the object. There's even an equation that says force equals mass times acceleration. I know. That means the harder you kick the ball, the further it will go. It seems kind of obvious, but having an equation to help figure it out mathematically helps scientists not just figure out, oh, a kid kicked a ball. It helps with more advanced stuff, obviously. Okay? Anybody know what another name for the second law of motion is?
Oh, let me check. So I get a random...
Velocity? You're on the right track. That's not it. What do you think?
The second law of inertia?
No, that's a good guess.
Hold on, I know.
Good guess. What do you think? What do you think?
Change in force and mass.
No. But what is change of force and mass? What did we just talk about?
The second law of momentum?
Acceleration. It's known as the law of acceleration. Okay, the second law is also known as the law of acceleration. Okay? Third law of motion.
Action reaction.
There you go. He already nailed it. It's known as action and reaction. Okay? The third law states that for every action, there's an equal and opposite reaction. That means there's always two forces that are the same. In an example where you kick the ball, there's the force of your foot on the ball, but there's also that same amount of force that the ball puts back on your foot. The force is the exact opposite direction, okay? Think about your bottle rocket, okay? Depending on the amount of force that came out of that bottle, depended on how high it went, okay? Coming out was the action. The rocket or the bottle taking off into the sky was the reaction, okay? That was the reaction, okay?
Wait, what is a reaction for?
It is said that Isaac Newton got the idea for gravity when an apple fell off a tree and hit him in the head. I don't know if it actually hit him in the head, but the story does have it that he watched an apple hit the ground and he was like, oh, wonder why, something is causing things to fall down. So
I would say.
he did the math and figured it out. Force is measured in newtons. This is after Isaac Newton, not Fig Newtons. Okay? Fig Newton is a little cookie-like thing. Okay? Yeah, they're kind of gooey. Pretty good. You're not bad.
I do not like
All right. Now, a lot of people don't. I understand they were not named after Isaac Newton or even the fig. They were made in a small town in Massachusetts, and it was named after that area. I have no idea if that's true or not, but that's a story I read. Gases and liquids push out equal forces in all directions. This is called Pascal's law because it was discovered by a scientist named Pascal. We will talk about that a little later on too. When you go upside down on a roller coaster, the loop-de-loop, a special kind of force called centrifugal force holds you into your seat and keeps you from falling out. Okay? Because you're going so fast that you do not fall. That force is holding you up.
They strap you in while you're standing up, they spin you really.
Yep. Pretty much anything that holds you into place like that is centrifugal force. Okay? All right. Yes, Braxton.
Is it named after Cam Newton in celebration that he's going in the future?
No, Cam Newton doesn't have enough brains to throw a football down the field and hit it open.
That's not a burn. That's not a burn. It's a fact.
Okay. Hey, when you stating truth is there's nothing wrong with stating truth. I'm not a big Cam Newton fan, just to be honest with you. So it was kind of a burn. Stop. We're not going to start discussing football. Okay? Okay? All right, we're going to move on to momentum and collision. Momentum and collision. Okay? All right. Momentum is a measurement of the mass of motion. Any object that is moving has momentum. In physics, momentum of an object is equal to the mass times velocity. Okay? So momentum equals mass times velocity. That's the formula for that. Yes, Caleb?
Whenever somebody insults a person, they always say that they're just stating the truth.
That is what they say.
That's what I say to Morgan.
Sometimes.
Whenever you go against a fantasy football team and they have Cam Newton, you're like, okay.
Y'all did hear me say we're not going to discuss football, right? You're my witness. 2 questions. Back to back.
But then again, Mr. Satchel, don't ever watch
And here comes the third. That's true. I couldn't tell you how well he's doing in the last 3 years because I haven't watched football in 3 years. Okay. Momentum is usually abbreviated. Now listen to this. Momentum is usually abbreviated using the letter P. Okay? So the equation looks like P equals M times V. Okay? So it is actually, but think about it, and he's going to tell you in a few minutes that no one really knows why. My guess is mass was already taking up the M. And so if you try to get try to do too many M's and even with special markings or whatever, it's going to get confusing. From this equation, you can see that both the velocity of the object and the mass have an equal impact on the amount of momentum. You have more momentum when you're riding than when you're walking, obviously. By the same token, if a car and a bicycle are going down the street, and both of them are going 10 miles an hour, which one has more momentum?
The car.
The car, because it has more mass. Okay? You get hit by a bicycle, it might hurt. You get hit by a car, it will definitely hurt. Okay? So you're going to see the difference there. Okay? Even at 10 miles an hour. Okay?
10 miles an hour can kill you.
Well, I didn't want to get into specifics, but yes, it could.
My dad got ran over by a car.
No, it didn't.
Momentum! 3-day weekend, boy, or we completely lost it. So it's only going, you're going to see it get worse as the holidays approach. I would just be standing for screaming, be quiet, be quiet, be quiet, okay? So just be ready, okay? Momentum is typically measured in kilograms times meters per second or newtons second, okay? So Newton is, of course, measured or written out as the big N with the little s, Newton seconds, okay? Momentum is a vector. Anybody remember why? What does things need to be a vector? What is it?
Doesn't it need to have a direction and a magnitude?
There you go. Oh boy.
This means
Because velocity is a vector, momentum is also a vector. This means in addition to the magnitude of momentum, okay, momentum also has a direction. Okay? The direction of momentum, of course, they draw that out with an arrow to show. Leo, please put your chair on the floor.
Yes, sir.
Thank you. Collisions. When two objects, now this is where it can start to get a little confusing if you're not careful. When two objects bump into each other, this is called a collision. In physics, a collision doesn't have to involve an accident like two cars running into each other, but can be any event where two or more objects exerts force on each other for a short period of time. So we think about a collision, we think about two objects running into each other, two cars, two people, whatever. Okay, walking into the wall. I mean, that's a collision in all reality. Okay? An example is one ball striking another ball on a pool table. Okay? That is basically a collision. A baseball bat hitting the ball. That's a collision. Okay? Your fingers striking the key on the keyboard. Scientifically, that is a collision. Okay?
Isn't that because once you press it down, the button comes back up? It does.
Okay? An important theory in physics is the law of momentum conservation. This law describes what happens to momentum when two objects collide. And again, this can get a little confusing if you're not careful. The law states that when two objects collide in a closed system, the total momentum of two objects before the collision is the same as the total momentum of the two objects after the collision. Okay? The momentum of each object may change, but the total momentum must remain the same. Okay? That can get a little bit confusing. I have people in here has not paid a lick of attention. Thursday's their test. That's going to be fun. Okay?
For you.
The good part is January the 14th, the day before the end of the quarter, I will get 40 emails, and there's only 30 some of them. I will get 40 emails wanting to know, what can I do to get my grade up?
I never send it.
Okay?
I've not seen that email.
Some people will send it 18 times. Because the answer they don't like. Pay attention to next class. Starting next quarter, pay attention to what we're doing.
Wait, I understand.
Well, you'd be surprised how many people don't. All right. If a red ball, here's an example. If a red ball with a mass of 10 kilograms is traveling east at a speed of 5 meters per second, and it collides with a blue ball with a mass of 20 kilograms, and it's traveling west at a speed of 10 meters per second, what would the result be? Okay, so to figure it out, you take the red ball, 10 kilograms times 5 meters per second would equal 50 kilograms meters per second east, because that ball is traveling east. Okay? The blue ball is traveling west. So you would take the 20 kilograms times 10 meters per second. That gives you 200 kilograms meters per second west. When they collide, okay, the resulting momentum will be both balls now equals 150 kilograms meters per second west.
So you subtract.
Because if you subtract the 50 from the 200, because the big ball, okay, the heavier ball traveling at a faster speed, when it collides with that smaller ball, it's going to drive the smaller ball back. Okay, it's going to have more momentum, so it's going to drive it back. So you subtract the weight of the momentum of the red ball. Now, if they're both just standing still, they have no momentum, okay? They have 0 kilograms meters per second, okay? All right. No one is quite sure why the P is used for momentum, okay? A change in momentum is called impulse. An elastic collision is one in which no kinetic energy is lost. An inelastic collision is one in which the kinetic energy of the colliding body is lost. And this is because the energy is now converted into another type of energy like heat or sound. Remember, heat or energy cannot be destroyed. It can be transferred into another form of energy, but it cannot be destroyed. Okay, it doesn't just go away. The recoil of a gun is because of the conservation of momentum. The gun moves back at a lower velocity than the bullet because of its greater mass. Okay, you can imagine if you fired a shotgun and the kick on that thing, it kicked back at the same momentum that bullet is. You would be picking yourself up every time you shot that shotgun. Okay, because that bullet comes out of there at an amazing rate of speed. Okay? All right. We're now going to hand out homework questions, watch some couple of videos, which again I will include in your on your classroom page. I've lost my main thought there. Bye.